This is practice test number 1, problem number 5, and we have a set. The following is a set of data from a sample of n equal to 7. And so we have 7 data points for x and y. And we are asked to compute the correlation coefficient for the variables x and y. And in order to compute that correlation coefficient, we're going to have to fill out this following table. The correlation coefficient will tell us if there's a relationship between the x and y values and how strong that relationship is. So we're going to begin by filling out this table, and the table is all set up for you to fill out. In the first column, we're going to have the x values that are listed here, and they're the same as what is given up here. They're just listed out in this column. We do the same for the y values. We list them in this column here. And then in the third column, we're going to square all of the x values. So the 2 squared gives me 4, the 4 squared gives me 16, and so on. All of the x values are squared in this column. Then we would do the same thing for the y values in this column here. 3 squared gives me 9, 2 squared gives me 4, 6 squared gives me 36, and so on. All the y values are squared. In the last column, we're going to have xy, which is the x value times the y value. So, for example, we would take the 2 times the 3, and that would give me 6. 4 times 2 gives 8. 5 times 6 gives me 30. X, y values squared, and so on down through this column. Now when we get done, we're going to sum up each column. So we're going to take the values of x, add them all together, and we get 36. And we do the same for each column. All the y values added together gives me 30. All of the x squared values summed up gives me 210. The y squared value summed is 144. And the xy values summed up gives me 168. And this little symbol over here, you've seen it in class. It's the capital sigma. It means the summation of all those values. So that's what these represent down here, the sums of all these values. And when we come to letter B, now we are going to calculate the correlation coefficient. And so letter B says, using the following formula, substitute the values from the table and calculate the correlation coefficient and show all work. Now it's a complicated looking formula, and we just have to be careful that we place the right numbers into the right places here. So we start on the top, the numerator, and the n is 7, and you can see how I've done it here. The sum of the xy column is right here. Here's the xy column. The sum of that column is 168. And so I'm going to multiply 7 times the 168. When they're next to each other like this, that means multiplication. And then I'm going to subtract the sum of the x column, which is 36, times the sum of the y column, which is 30. And you see 36 times 30 right here. Now when I do this calculation in the numerator, I end up with 96. And then I want to do the denominator. Now the entire denominator is under a square root. So you're going to have to take the square root of everything inside of the square root. The inside the square root, we have 2 quantities that we're multiplying together. Here's one of them in this bracket, and then we have a second quantity in this bracket over here. These 2 things are multiplied together. So we begin with this first quantity here in this bracket. We have n, which is 7, times the sum of the x squared column. And the sum of the x squared column is the 210 right here. And then we're going to subtract from that the sum of the x column squared. Now we should be careful here. This is the sum of the x column, which is 36, and that 36 is squared. It's the sum of the x column, 36. It's not the sum of the x squared. It's the sum of x column squared. So there's a difference there, and that gives us the quantity in the first bracket. Then we go to the second bracket here. We have n, and it's going to be n 7 times the sum of the y squared column, which is the 144. So it's 7 times 144. Now I should have another parentheses right here indicating 7 times that. And then we are going to subtract the sum of the y column squared. The sum of the y column is 30 right here, and it's squared. So it's going to be 7 times 144 minus 30 squared. And that's going to give me a second quantity right here. Now, when I take these two quantities and multiply them together, I get 18,792. When I take the square root of that, I get 137.0839. And then when I do the division here of 96 divided by the 137.0839, I get this value here of 0.7003. And this is my correlation coefficient. The R is what the symbol is used for it, and it's called the correlation coefficient. And now I am able to answer the two questions at the bottom of the page. Interpret the correlation coefficient by answering the following questions. Number 1, is this a weak, moderate, or strong relationship? And a 0.7, we would call that a strong relationship. Anything between 0.6 and 0.8 is a strong relationship between the two variables, x and y. And then number 2, is this a positive or negative relationship? And because this is a positive number, then the relationship is a positive relationship. It is possible to have a negative number, and we would have a negative relationship. So that is problem number 5.